In this lesson, we're going to be using what we've learned about scale drawings and what we already know about proportions. Reading the problem below and then exploring how to use scale drawings to find actual measurements using what we know about proportions. Below is a scale drawing of a soccer field. A length of 1 centimeter in the drawing corresponds to 15 yards in the actual field. Find the dimensions in the area of the actual field. So this means that our scale is 1 centimeter to 15 yards. Let's look at a few ways that we could use what we know about proportions to answer the question. Find the dimensions and then the area of the actual field. So first, we can measure it. You can look at the labels to find the measurements of the drawings. The width of the field in the drawing is 5 centimeters. The length of the field in the drawing is 8 centimeters. Remember, the drawing is not the actual size of the field. So let's take a look at how we can model this. And we can model it with a table of equivalent ratios. And we're going to use the scale that the problem gave us, that 1 centimeter equals 15 yards. And you can see that that is our first ratio on our table, 1 centimeter per 15 yards. We can use that to fill in the rest of our table, going from 1 to 8. Remember, we do this by taking that scale factor of 15 and multiplying it by each one of the numbers in our table. So 2 times 15 is 30. 3 times 15 is 45. 4 times 15 is 60. 5 times 15 is 75. 6 times 15 is 90. 7 times 15 is 105. And 8 times 15 is 120. And remember, from this table, the 5 centimeters and the 8 centimeters are our two ratios that we're interested in, because based on our drawing, we have a length and width of 5 and 8 centimeters. So let's look at how we can take this table of equivalent ratios and model it with what we know about proportional relationships. So first, you can see the first ratio in our proportion is our scale factor, 1 centimeter to 15 yards. That is equal to one of the distances we're trying to find, which is 5 centimeters. So remember, we're drawing this from our drawing to our actual. So we want to make sure that that stays consistent throughout the whole proportion. So we want to make sure that our 5 centimeters is on top. And the actual distance we don't know, so we use x. Then we use the same scale factor, 1 to 15, to set up our second proportion that helps us find that length. And we know that the length of the scale drawing is 8, but then we don't know what the length of our actual is, so we use x. So we can set up two proportions, one proportion to solve the width, and then one proportion to solve the length. Let's answer a few more in-depth questions to get us thinking more about how to use those proportions to solve the problem. Look at the first modelet. We completed the table. Explain how you figured out the missing lengths. So taking a look at the page before, and we completed our table with the 60, 75, 90, 105, and 120. So this first question wants us to explain in our own words how we calculated those numbers. Go ahead and pause the video and write in your own words how we filled in the rest of that table. So we took our scale factor of 15 and multiplied it by each drawing length. And remember, we were particularly looking for the 5 and the 8 because those were our drawing lengths from the problem. Use your table to find the actual length and width of the field. So using that table, we know the drawing had a width of 5 centimeters, which corresponds with which width of our actual. So taking a look at the top of our table, we can see that 5 centimeters corresponds with 75 yards. Then the drawing's length, which is 8 centimeters, which corresponds with what? 120 yards. So looking at those equivalent ratios that we made throughout the whole table. So let's look at answering that same question, but with our proportions. So look at the second modelet. Use the equation to find the actual length and width of the field. So you can see that they have this proportion set up for us. And what we can do is we can cross multiply and then divide to find this missing piece. So we're going to cross multiply 15 times 5, which equals 75, and then 75 divided by 1, which equals 75. So a width of 5 centimeters on the drawing equals 75 yards on the actual field. So your part over here, you can see I kind of skimmed over that a little bit. This is just where they were showing that cross multiplication, and sometimes the way this is written can be confusing for students. So as long as you remember you cross multiply and divide, you'll be good. So then looking at the same thing for our length. Again, we're going to be cross multiplying 15 times 8 and dividing by 1 to get that missing piece. 15 times 8 equals 120, and 120 divided by 1 equals 120. So a length of 8 centimeters on the drawing equals 120 yards on the actual. So we get the same thing whether we use a table of equivalent ratios or a proportion in cross multiplying and dividing. Then number 5 asks us to calculate the area of the actual field. Remember, the original question wanted to know the dimensions, which was our 75 yards and 120 yards. Then it wanted us to take those dimensions to calculate the area. Remember, to calculate area, we multiply our length times our width. So to calculate the area for this problem, we want to multiply 120 times 75, which equals 9,000. And we're talking about yards, and we're talking about area, so it's yards squared. So now we want to explain how you can find an actual distance when you know a distance on a scale drawing and you know a scale. So in your own words, explain how you can find that actual distance when you know the distance on a scale drawing and the scale. Pause the video and explain that in your own words. So there's two ways you can do this. The first way is to make a table of equivalent ratios. Using your scale factor to fill in. Remember, your scale factor is when you're comparing to 1. So that number compared to 1 is what you would multiply throughout the whole table. Or you can set up a proportion. Well, set up a proportion, which is an equation, and solve. So that's where we cross multiplied and divided. Describe two properties that the vertical line in the center of the scale drawing shares with the actual vertical line in the center of the soccer field. So going back to that original picture of the soccer field, it's asking us to compare this vertical line here in the middle with the center, or with the scale drawing, compared to the actual vertical line on the actual soccer field. So how can you compare those two things? What would those two things have in common? What would they not have in common maybe? Pause the video and write your thoughts down on number 7. So there's two things you may have noticed about this vertical line. So that vertical line, actually there's probably 3 things. So the vertical lines are proportional. So the vertical line to the actual compared to the vertical line of your drawing is going to be proportional, just like your word length and width are proportional. Also, your vertical line is going to be perpendicular to the longer side, or the length, and it's going to be parallel to the width. So 2 words you may not have heard in a while, but we definitely know what they mean. So 3 things that you can tell about that vertical line running through the middle. It's also going to be proportional. It's going to be perpendicular to your length, and it's going to be parallel to your width. Let's take a look at a couple more examples. Number 8, on a scale drawing, a building is 5.5 inches tall. If the scale of the drawing is 8 inches to 1 foot, how tall is the building? So I would recommend setting up a proportion to solve this one. You can definitely do a table of equivalent values, but since this length or this measurement we have here is 5.5, it's probably a better idea to set up a proportion. Number 9 says, for a school project, Leo is making a model of the Statue of Liberty. He is using a scale of 2 centimeters to 3 meters, and the Statue of Liberty is 93 meters tall. How tall is Leo's model? So this is one where you can set up a proportion, or you can do a table of values. Go ahead and pause the video and calculate the answers to these two problems. So on number 8, when you set up your proportion, you have 1 inch to 8 feet. So 1 inch on the drawing to 8 feet in real life. And then on the scale drawing, a building is 5.5 inches tall. So that 5.5 is going to line up with my 1 inch. Over, we want to know how tall that is in actual life. So that's going to go on the bottom. So we're going to cross multiply 8 times 5.5 and divide by 1. So when you cross multiply, you're going to put 8 over 1 times, we want to change 5.5 to 11 over 2, which is 88 over 2, so we multiply straight across, and 88 divided by 2 is 44. So the building is actually 44 feet. And then for number 9, if we set up a proportion, it's 2 centimeters to 3 meters. And then the Statue of Liberty is actually 93 meters tall. So that's going to line up with our meters. So it's going to go on the bottom. So again, making sure everything's lining up. And then we're going to use X for how big it is in the model. So we're going to cross multiply 93 times 2 divided by 3. So 93 times 2. 2 times 3 is 6. 2 times 9 is 18. So then we're going to do 186 divided by 3. And I'm going to come over here to the side. So 3 into 186. So 3 is going to go into 18 6 times. 6 times 3 is 18. Subtract, we get 0. Bring down your 6. And then 3 is going to go into 6 2 times. For 62 centimeters.